Douglas here from WinkNet Labs. In this video demonstration, I'm going to be walking you through level 8 of the second Capture the Flag challenge offered by InfoSecInstitute.com. Now, the URL for this is ctf.infosecinstitute.com/ctf2, and you can access the exercises/levels in the levels menu here in the top left. Just click on it, scroll down to 8, and click on 8. Now, it looks like we're presented with a simple web application that allows us to upload images. Our task is to penetrate this site. You need to take advantage of the image upload and execute a JavaScript with an alert somehow through a file. Godspeed. Okay, so let's just put in some garbage here and try and upload an image. I have saved an image here. Whenever you're in Weaker Than Linux 6, by the way, and you're using Google Chrome runs as the user weaknet. It doesn't actually run by the user root. So everything will be downloaded inside of the weaknet home directory. So we're going to select this image here, hit Add Image, and let's see what happens. Image uploaded successfully, but we don't see it anywhere. Why don't we see it? Let's right click on the document, go to Inspect Element, and then in the Developer Tools, we're going to select Network, and we're going to try and upload it again and see exactly what's going on here with our network traffic. Is it just JavaScript doing this, or is it actually going up to their server? So add image. It's not JavaScript. Look at that. ex8.php is called. It most likely is the handler for this form, as it usually is for the other exercises. And it looks like everything else is just JavaScript, style sheets, and the font stuff there. So try using another okay, so that makes sense. Try using another name for your file. That means our file was successfully uploaded. The 3ss_pwnt.jpg was uploaded. We just need to figure out where it goes. So here's 3 clues right here. Let's right click on one of these, go to Inspect Element, and it looks like there's a get parameter attach_id. Let's right click on that and go to Open a New tab. Ah, look at this. This could be SQL injection here. I would definitely try SQL injection here. But before going on with something like that, let's just think simple. I'm going to right click on the image, inspect element, chess. So this is definitely the image that's attachment_id. It's most likely ID, and then maybe the XPath for the image, most likely in their MySQL database. Not sure. I'm going to right click on the actual image and go to Open Link in New Tab, so we can actually see that this is where this image is stored. Now, this web programmer may have put our images in the same place, so let's test that. Let's go 3ss_pwnt.jpg, and yeah, 800 by 800, our JPEG is loaded, even though it was slow. So I got this image uploaded now. So how do we get JavaScript to alert through here? Well, instead of uploading an image, let's just try and upload an HTML file. So I'm going to use Vim. And again, I'm going to go into the CD home weaknet. Okay, there's nothing in there. Vim. Let's do html.html. Actually, there may be some checking for that. Let's just put file.html. And in here, I'm just going to put script. And then I'm going to do alert punt. And we're going to end the script tag, and Vim is going to fix the tab indentation for us automatically. Nope, I must have typed too fast. Whatever. Let's just save this file, and let's try and upload this file. Now, in this file, again, is just a simple JavaScript alert within 2 script tags. I'm sorry, an open script tag and closed script tag. It's not a full HTML document. It's just like a piece of one. Okay, so let's go back here and let's try and upload this file. Let's keep the network here open, make sure that we are calling ex8.php. Let me move this down for you here, and let's select file.html, open, add image, and let's see what's going on here. Your file does not have the proper extension. Okay, well, it's probably checking for HTML. Let's change it to file.html. Let's change it to file.js, see if that works. And I have another idea just now. Maybe it's not just looking for HTML or JS. Let's just test this really quickly. It could be looking for a string, And if it's using some sort of regular expression to validate this, look, it does not have proper extension. Then if they're not anchoring the regular expression using the anchor caret or dollar symbol, then we could have something like, actually, let's just try it. Move file.js to file.jpg file.jpg dot, I don't know, HTML. Let's see if that works. That way it's only like partially validated, it's not fully validated. Let's see, choose file, and let's do the JPEG and add the image. Okay, file uploaded successfully. Look at that. Now we just have to access that. So to access that, let's go back here, and let's see, we called it file.html, or I'm sorry, file.jpeg.html. Oh, look at this. Look at this get parameter here, file equals. Hey, look at that. That was really easy. Okay, that was extremely simple. But let's take note of that right there. I want to go back there, actually, because that looked vulnerable to me. This right here. Let's copy this, and let's see. Let's try to open a different file, like etc pass. Oops. JavaScript protection. It's very funny. Password. Let's try and open the password file. Okay, looks like nothing happened. Let's go deeper into the file system. Nothing happened. Let's go a little bit deeper into the file system. Nothing happened. Let's try a couple more times, because most likely that doesn't go this deep for the web root. This is probably just grasping for straws as usual, brute forcing something here. Oh, look at that. File does not contain the right code. We hit this file. We successfully got PHP to read their password file, but the password file did not contain the script tags. The script and the JavaScript alert. So that's exactly what they're looking for. They're looking in the, okay, I know what they're doing. The PHP is looking for the actual JavaScript code in the file. So how the hell do we get that inside of a file that we? Oh, how about the log? How about the log? Let's change our user agent here. So let's go to options. I have an idea. Okay, so every single time you hit a web server, right, your user agent string gets stored inside of a log file. Now that we can read files on their file system, if any of those files contain the JavaScript code that the PHP is looking for, it'll read that. Now, imagine if, because it's reading it, imagine if there was PHP code in it. For instance, if this works, let's see, let's just call this JavaScript alert. And let's just put script alert pwnt, oops, pwnt, and let's just finish the JavaScript tags. Let's make a new group called hacking, and I don't know. Okay, so, okay, look, it was made here. Okay, so this becomes my user agent string, which means every single time I hit their web server, this goes into their log file. So that means that I should technically be able to read their log file because this string exists in there, right? Because I was able to read the etc password file, it's just that string didn't exist in there. Now, once I'm successfully able to read it, because here, let me just hit their web server. And once this successfully loads here, okay, so I hit their web server, right? But this, actually, maybe this went into the error. Actually, because it failed gracefully. Maybe it didn't go into the error, Apache error. Anyways, so what happened was my user agent string with the JavaScript went into their log file. Now, if I could somehow find their log file, var log Apache 2, let's see if I can read this directory. Look, I think I was able to read that directory. Let me just foobar this up a little bit. Put an F there, hit enter. Okay, my theory is correct. See, Apache 2F does not exist on the file system, so nothing happens on the DOM, nothing changes. Now, whenever we hit a directory or a file, then it changes and it reads the actual directory or file for our JavaScript code. So we need to figure out the version of with the server that we're looking for and the actual version of Apache that we're looking for. And the easiest way to do this, I think, is to just hit nothing. Let's try lol.php. Look, 404. Yeah, see, we glean this information from this they don't have a custom 404 page, so we actually get to see this. It's Ubuntu, and it looks like it's an older version of Apache 247. So I'm pretty certain that the log would be access, and Debian is .log for that version of Apache. Let's hit it and see what happens. Okay, so that actually wasn't it. Let's try underscore. Okay, that's not it either. Let's try httpd underscore access underscore log. It's loading quickly. It's probably going to load take a long time to load once we actually hit it. So let's go to httpd access log, and then we'll get rid of the d also. See, this is just brute force again. It looks like this method will actually work if somebody were so inclined to actually just keep trying different file names until they actually hit the log. Once you do actually hit the log, that would be way beyond the scope of this video. But once you actually do hit the log, what you want to do is change your user agent string to into something that is PHP code that reads a different file. So from there, you could put any PHP code in your user agent, which means you can use a preg replace, which means you can use a regular expression, and you can replace all of the anchor tags to actually be ampersand less than tags. That way, it actually outputs the PHP code itself, the source code, and not execute it. So that way, you can actually read any file on the file system. This method most likely works, and this flaw definitely works. It would just take far too long probably to find the actual name of the actual log, since it's most likely custom. Let's see if we can hit etc Apache 2. Yes, so etc Apache 2 exists. Let's try log access.log. I went a little bit too deep there. I should have just tested log first. Yeah, access.log does not exist. Let's try log. Log does not exist either. Okay, yeah, I went a little bit too deep there. Let's try conf. Conf doesn't exist either. Look at that. I can hit their Apache configuration. So with this, you can actually map out their file system. You just can't actually read the contents of the files until you can exploit the log injection vulnerability that I just described.